To look at network traffic, we need to use what's known as a network protocol analyzer. One of the most popular is WireShark. WireShark is free to use and runs on many platforms, and for this module of the course we'll run WireShark on a PC. You can download WireShark from www.wireshark.org. I have WireShark installed already, so let's go use it. WireShark provides a front screen with 4 sections: Capture, Capture Help, Files, and Online. There's often a lot of packet activity on a network, so when using a network protocol analyzer it's common to capture packets into a file and then analyze them in slower time. These files are known as PCAP, or Packet Capture Files. The WireShark website provides many example PCAPs that you can use to get familiar with packet level communications. You can visit the website from this front page using the top link in the online panel, and you can access the sample PCAPs through the link in the Files panel. Let's do our own capture. The first thing I'll do is select the network interface I want to use. In the area titled Capture, just below the Start caption, you can see the list of interfaces on my computer. There's only one, so I'll press Start to begin using WireShark. Just for the moment, I'll stop the capture by pressing the red square on the icon ribbon. The WireShark screen has a set of drop-down and button controls at the top, and 3 data areas below that. The top data area shows the list of packets that WireShark has captured. Rephrase. The top data area shows the list of packets that WireShark has captured this session, 1 line per packet. The second area shows the format of the packet, and we'll spend some time looking at that shortly. The bottom data. Let's reopen the PCAP that I captured by selecting My First PCAP in the Files area of the WireShark front screen. WireShark now loads the file, and I can start analyzing my website session. Let's look at packet 101. We can see this is a DNS method packet with standard query in its information field, as well as a reference to www.wireshark.org. While we call this website www.wireshark.org, computers don't understand this name. They need to have a numerical address in IP format so they can communicate. The DNS server is where a computer goes to find this address, using the DNS protocol. If we look at the next packet, we'll see that this is a standard query response with 162.159.242.165 in its information field. If we open the field called Domain Name System in the middle panel, we see that this expands and provides more fields. It highlights that this is a response to packet 101 and provides 2 additional fields called Queries and Answers. Here we can see the original query and the 2 answers provided by DNS. 162.159.242.165 and 162.159.241.165. This indicates some form of load balancing is occurring across the 2 systems. So now we know that the website www.wireshark.org can be accessed by either of these 2 addresses, and DNS suggests the first. Let's go down one more line. We can see in the information field that this is a reference to HTTP SYN, and it has a source address of 10.1.1.3 and the destination is 162.159.242.165. If we hover over it and right-click, we can set a conversation filter for TCP. We can see that this has set a filter and that the packet display is limited to just this website exchange. The first packet is a SYN. If we go to the second packet in this conversation, we can see that this is going from source 162.159.242.165 to destination 10.113, and that this is a reply to our SYN request. It's a SYN ACK. Below that, we see another packet from 10.1.1.3 to 162.159.242.165, and this is an ACK. So here we have the complete TCP 3-way handshake: SYN, SYN ACK, and ACK. Once this handshake's complete, we've connected to the website. Below this packet, we can see an HTTP packet. If I hover the mouse over that and right-click, and select the option to follow TCP stream. A new window appears with the HTTP coding extracted from the packet and displayed in red. Beneath this is another packet displayed in blue. This is the HTTP 1.1 200 response, which shows the GET request was successful. We can see that this has come from a Cloudflare server. Following this is the packet content, which in this case is an image in the JPEG file interface format, or JFIF. Let's go back to that first HTTP packet and look inside the middle panel. I'll click on Internet Protocol version 4, and we can see that WireShark highlights the line in blue and highlights the associated bytes in the bottom panel. Let's click on one of the fields in the IP header, the one that shows the total length, 677. That highlights just 2 bytes in the bottom screen, 02, A5. A here is the representation of 10 in hexadecimal. 02A5 is the representation of 677. 256 times 2 plus 10 times 16 plus 5. A bit further down, we can click on the line that starts source 10.1.1.3. We see in the bottom panel the 4 bytes 0A, 01, 01, 03 have been highlighted. So WireShark provides us with a great deal of intelligence about the structure of many packet types, and we can use the middle panel to explore the contents of the packet through its structure. I'll remove the filter by pressing the clear button to the right of the filter edit box, and WireShark will display all of the packets again. One of the key ways we can improve our effectiveness when analyzing network data is to remove a lot of unnecessary packets and concentrate on just the packets we want. I've already used the Follow TCP Stream filter, and I've used the Conversation filter. Let's just take a brief tour of some other filters and filter expressions we can use. I'll press the expression button to the right of the filter edit box. This causes WireShark to display a filter window. The left-hand part of the window is a list of fields I can use, the middle part is the operator, and the right-hand part the value. If I type the letters DNS, we see the list move to the DNS line. I'll expand the DNS fields, and I'll move down to find the DNS query name line. I'll select the operator equals, refresh. I'll select the operator contains and enter the value WireShark and press OK. We can see the edit box is green, so the expression is valid. If I put an X on the end of the expression, the box turns red to indicate there's a problem. Let's remove that and apply the filter. Now we have only those DNS packets relating to www.wireshark.org, the initial address query and the response. Let's clear that. Let's try something a bit more complex. I'll press expression and type IPv4. Then expand that to find the field IP source. We can use WireShark to monitor for signs of an intruder. Let's assume we're looking for an intruder from IP address 10.1.1.15 to return. We can set up WireShark to capture any packets from this address that it sees. We do this using a capture filter. I'll click on Capture Options, Capture Filter. This allows me to filter at a protocol level, filter out noise, or filter by IP address. I'll select IP address and I'll enter 10.1.1.15 and press OK. And I can now start, and we're waiting for packets from the intruder to arrive. I'm ready to start an Nmap scan of this host from Scorpio. I can do this with sudo nmap-ps 10.1.1.3. We can see the port scan has finished. Let's stop the capture and have a look at it. At the start of the capture, we can see some SSH packets relating to the console interaction with Scorpio. But if we move down to the grey area, we can see the start of the Nmap traffic. We can see a TCP control packet with a SYN flag set. That's the first packet in a three-way handshake. As we can see from the destination port in the middle data area, it's a connection request to port 587. This is followed by another packet with a connection request to port 110. If we go down to the SYN rephrase, if we go to the SYN packet for port 135, we can see this is followed by a SYN ACK. Let's set the conversation filter. Here we have a rephrase. Here we have three packets: a SYN ACK, and a reset. We can see Nmap is trying to connect to ports, and when it does connect, it resets rather than complete the connection.